Okay, so good evening and welcome to this live session of problem solving for NPTEL course Control Engineering. So today's the problem will be based on week 2 video lectures, that is in Laplace transform and transfer function. So I hope we have gone through all the lecture video in the NPTEL course, so that will be easier then to solve this problem. So this Laplace transform actually gives a new kind of transform of the signal in the time domain to a frequency domain representation. So in the frequency domain means we have a complex frequency which have both the damping term and as well as the oscillation term. Okay, so this two-dimensional frequency domain space, and so benefit of Laplace transform is that it actually simplifies some of the expression, as you have already seen in the lecture video, like in an ordinary differential equation it will be like an algebraic expression, because this derivative will be s times the transform of that function. So you can simplify this expression, and that will in terms will help in writing the transfer function, that is the relation between the output and the input of an some control system, that any system that is represented by an input output, and a system it can be represented compactly using a transfer function representation. And we can just cascade or them, or they are parallel, you can just add them to obtain the transfer function of the overall system, provided that the loading effect is not present in that case. Okay, so we'll start solving this problem then. So we'll solve some basic problem on Laplace transform. So this problem 1, you can see that yt is the convolution of two signals x1 and x2 that are shifted by some terms, like x1 is shifted by -2 and x2 is actually +3, and this signal is time reverse signals. Okay, and x1 x2 are given the expression below. So then you have to find the Laplace transform of yt. Okay, so we can answer through poll first, then we can discuss this. Okay, so I'm starting poll for this question, so you first try and answer, then we'll discuss. Okay, so you can see the poll. Okay, I hope I'm audible and the slide is visible. Okay, if not, then please let me know. Okay, so please try, then we'll answer, we'll discuss this question. Okay, I hope the question is also clear. If not, you can ask. Okay. Use the properties of Laplace transform, and then you can find. Okay, I can't hear you. You're saying something.
20 is given two times.
Sorry.
Sir, in question third line, where x1t equals to e to the power minus 2t multiplied by ut, and second time x1t
Okay,
value is
sorry.
given.
This is x2. Okay. Thanks for pointing out. X2. Okay. Yeah. Okay, so then we'll discuss. Okay, anyway, so so use the property. Okay, so one property is the that the Laplace transform of convolution of two function is simply the product of the Laplace transform of individual function. Okay, so if you know the Laplace transform of this function and this function, then you just multiply them and you get the Laplace transform of yt. Okay, so first we calculate the Laplace transform of individual functions. Okay, and if x1 is this term, then you know that any function, okay, which is multiplied by some time shift like this, then you know that Laplace transform will be simply plus as f of s, where f of s is the Laplace transform of ft. Okay, so then using that property we can calculate the Laplace transform of this function x1t. Okay, sorry, I made mistake. Okay, let me correct it. Okay, so it will minus 2t f of t. Sorry, here we have f of t. Okay, this Laplace transform will be, okay, let me write. Okay, if it is x1t, its Laplace transform is x1s, then x1t minus 2, its Laplace transform will be simply the shifted version. Okay, so e to the power minus 2s x1s, right? And the Laplace transform of x1 here is simply, you have e to the power okay, x1t is given as e to the power minus 2t ut. Okay, and this Laplace transform then will be x1s will be 1 by s plus 2, right? Okay, so then Laplace transform of this one will be e to the power minus 2s by s plus 2. Okay, is it clear? Okay, I'm repeating again. Okay, so just use the properties of Laplace transform. Okay, so if x1t is Laplace transform is x1s, then you know that this is the property, like if you time shift it by some amount, then it will be the Laplace transform of this. So the Laplace transform, now you can compute the Laplace transform of x1s. Okay, x1x is given by this expression e to the power minus 2t ut. So again you use this property, Laplace transform property, that is if you multiply some function by e to the power of something, then you just change the s domain quantity, right? S. So you have minus 2t here, then you have, because Laplace transform of 1 by s is the Laplace transform of ut, right? Using that property we can find the Laplace transform of e to the power minus 2t ut. Okay, similarly you use for the second term, okay, x2. Okay, so first you find the Laplace transform of x2 function. Okay, we'll just write this Laplace transform of x2, which is, let we denote it by x2s. Then it is simply again using the same property that we have used for x1, it will be Laplace transform of 1 ut is 1 by s, so e to the power minus 3t ut will be 1 by, that is just shifted by this 3, that is the quantity that is in the exponential term. Okay, and if you now you see that in the x2 we have minus t plus 3, so the time is reversed there, so we can also write it x2 quantity as minus of t minus 3. Okay, so now we will another property. So first we know that first, okay, let first find this is t, let us find the x2 t minus 3. Okay, which is simply again e to the power minus 3 s, okay, by okay, okay, so yeah, Okay, so sorry, I made one mistake. Okay, so you see that you have to use this time scaling property, that is the time shifting property, that is if you multiply by minus t, then you simply get this Laplace transform will be x minus s. Okay, this is the Laplace transform of this function. So then you see that this is just, if you have used t minus 3, it will be s plus 3. So instead of s you substitute minus s there. Okay, so you have x2, this expression. Okay, so this expression will be, okay, e to the power minus 3s x to s. Okay, so instead of s you just put minus s, so the term will come out to be, okay, so x2, that is the minus 3 plus t, this Laplace transform will be then e to the power minus 3s, and instead of s you put minus s, so it will be 3 minus s. Okay, so now we have two terms, that is the first term's Laplace transform, which is we have computed it to be this term e to the power minus 2s s plus 2, and the second term Laplace transform we have computed e to the power minus 3s 3 minus s. So you are taking the convolution, so the Laplace transform of this convolution will be just product of this individual Laplace transform. Okay, so that means the final answer will be product of this term and this term.
Sir.
Huh?
Sir, in last step, exponent of minus 3s will be 3s.
Okay. So this, okay. So let me explain. So first, okay. So this sequence is just first you transform this, right? Time shifting, right? Then you apply this e to the power minus t on. Okay. Understand that?
Yes, sir.
So the minus 3s will not change. Okay. Only the function that is inside that x will shift, because this term is multiplied later, right, when you apply this e to the power minus t term. So this inside this expression will change, not outside. Okay, if Laplace transform x2 is x2s, this one, then inside that time shifting property will affect. Okay, so this, because this term is outside x2, it's not inside x2. Okay, so then the answer is e to the power minus 2s by s plus 2 and e to the power minus 3s by 3 minus s. Okay, this one. Okay, so then we move to next question. Okay, so in this question again you have to find the inverse Laplace transform. Okay, so the Laplace transform is given, you have to find the inverse Laplace transform. So you can answer through a poll. Okay, I'm starting. Okay, so we can answer, then we'll discuss. Okay, so you can answer through poll. I hope you can see the poll. You can do the partial fraction first to solve this. That is, try to find simpler form for which you know the Laplace transform. Then you can invert them. Okay, using the simple the relation between the what is the form of the function and this Laplace transform. Okay, the question is clear or okay, so then okay, we discuss this. Okay, so you know, like what forms you know the Laplace transform, right? For example, in the denominator here you have this term s square plus 2s plus 1. So have you seen some kind of forms for which the Laplace transform will be that form in the denominator? So
S plus 1 is square.
yeah, so so this is simply s plus 1 whole square. Okay, and you know the Laplace transform of like 1 by s 1 by s square, like this, right? You can find easily the inverse Laplace transform. But here you have s plus 1. Again, you know the shifting property, right? If you multiply e to the power something as a t, for example, in f of t, so the Laplace transform will be then whatever this if f of t Laplace transform is f of s, then you just put it s plus a here. Okay, so this is the form you know. So that means if you know Laplace transform of 1 by s square, then its inverse Laplace transform is what? T, right? So if some form is like this, that means it is simply t, but it's because of this term it will be multiplied by e to the power minus t. Okay, is it clear? Okay, for
Yes,
t,
sir.
for t, if not, then please ask. Okay, so if anything is not clear, you can ask. Okay, for t, you know 1 by s square, so e to the power minus t, it will be this form. Okay, so then we can find this Laplace transform of that. Okay, but you can see that in the numerator you still have some term like s plus 3. Okay, so you have to simplify them. So one way will be, okay, so we write it like s plus 1 plus 2 by this square. Okay, then it will be s plus 1 by s plus 1 square plus 2 by s plus 1 square. Okay, so it is simply 1 by s plus 1 plus 2 by s plus 1 whole square. Okay, this s plus 1 will be cancel out. Yeah. So then okay, so then you know like again you use the Laplace transfer property. So for t, you know it is 1 by s square, and for ut simply, or which is function is starting at the 0 point. Okay, so for there it is given t greater than 0, so instead of ut you can use just 1 also. Okay, because before that it is 0, after that is 1. Okay, so its transform is 1 by s. Okay, so then you use the, if it is multiplied by e to the power something a t f of t, then its Laplace transform will be, if the Laplace transform of f of t is f of s, then e to the power minus at f of t Laplace transform will be f of s plus a. Okay, so using that property, this a will be this term. Okay, so here you see that this shifting is by 1, so it will be multiplied by e to the power minus t only. Okay, so the first term, so writing the inverse Laplace of this expression. Okay, the first expression, it will be e to the power minus t. Okay, the second one, you can write it multiply by ut also, but because it is given for t greater than equal to 0, so ut value, so this is the ut function, the unit step function. You see that for t it is 0, so t greater than 0 its value is 1, before it is 0, so after this it multiplied by 1, so even if you write it ut, so this will be just 1. Okay, and this function, as you can see, it will be t again shifted by this 1, so it will be e to the power minus t. Okay, and this coefficient 2 is there, so it is 2 times of this. Okay, and because this ut is 1, so again I can write it as 2 e to the power 2t e to the power minus t plus e to the power minus t. Okay, this expression, which is the first one. Okay, Is it clear? Okay, so we'll move to next question then. Okay. So you have to find, so this sign is means convolution. Okay, so you have to find the convolution of e to power minus t with sin t. Okay, so you can apply the convolution theorem and you can find the answer. So the convolution theorem, what is that? So this convolution calculating in the time domain is difficult, right? You have to shift the signal and find the integral of that. But using the Laplace transform, you know that the Laplace transform of convolution of two signal is simply the product of the Laplace transform of individual signals. Okay, so using that property, you can find the Laplace transform of this convolution, and then again you can find the inverse Laplace transform to find it in the time domain. Okay, is it clear? So what you do? So you are given some signal f of t convolution with g of t, where f of t is this e to power minus t and g of t is sin t. So you find the Laplace transform of f of t and g of t individually. Let it be f of s and this will be g of s. Then you know that the Laplace transform of this convolution is same to just the product of this f of s and g of s. Okay, so you can find the product f of s and gs, and then you can take the inverse Laplace transform. So you take the inverse Laplace transform of f of s, g of s to find it in the time domain, which will give the convolution, right? So use that thing to find. Okay, so I'll start this poll. Question is clear? So please let me, if the question is not also clear, you can ask. Okay. Okay, so I think you can see the poll, so you can try and answer. Okay, so what you do? So find the Laplace transform of this e to power minus t and sin t, because it is a convolution operator. So in the Laplace domain, it will be just the multiplication of this Laplace transform of e to power minus t and sin t. Okay, so that expression will give some expression in terms of s in the frequency domain or in the Laplace domain. So then find the inverse Laplace transform. So this will result in the time domain. What will be the expression for this convolution? Okay. So try. Okay, so okay, let's discuss this. Okay. So as I say, okay, I will read this. Okay, so okay, anyway, so what we have, you know that f of t convolution of some g of t, two time domain function are given and their convolution is given. Or the Laplace transform of this is simply, if the Laplace transform of f of t is f of s and this Laplace transform of g of t, let it be g of s, then the Laplace transform of this convolution is simply f of s multiplied with g of s. Okay, so we'll use this property first. So first we find, let here the f of t is e to power minus t and this g of t is sin t. Okay, so for f of t, the Laplace transform will be what? Then e to power minus t. What is this Laplace transform of that? So it is 1 multiplied
1 is 1.
sorry, 1
upon s plus 1.
Yeah, correct. So it is 1 multiplied with e to power minus t, so its Laplace transform is simply 1 by s plus 1. Similarly, sin of t, what is the Laplace transform of this?
1 upon s square plus 1.
Yeah, so here we have, this is omega t, so here is omega is 1, so it will be omega by s square plus omega square, and omega is 1 here, so we have 1 by s square plus 1. Okay, so then this Laplace transform of e to power minus t convolution with sin t will be multiplication of these two transform, this f of s into g of s, so it is simply 1 plus s multiplied with 1 by s square plus 1 this. Okay, so now we have to find the inverse of this expression to find what will be this expression of convolution in the time domain. Okay, this is because this is in the s domain or in the frequency domain. Okay, for that what we have to do, again we have to decompose it into simpler expression for which we can find the Laplace inverse transform. Okay, so one way is like partial fraction. So partial fraction means you, so okay, so let me write this. So if you anyhow you can decompose this into some summation of some simple terms, then you can find the inverse Laplace transform. Okay, for example, if it can be decomposed into some terms like this. Okay, bs plus c s square plus 1, because you already know if in the denominator if these terms are present, you already know that you can find the inverse Laplace transform. Okay, so you have to but it is multiplied in the denominator, right, two terms for which we cannot find, so you have to separate them. So what you want, that is this expression you want to decompose into this form, some simpler form of this, where a, b and c are some coefficient which we don't know, we want to evaluate them. Okay, for which coefficient these two expression, that is the first expression, that is the multiplied term in the denominator, will be equal to the summation of this term. Okay, so this is called partial fraction expansion. So let's do how we can find this a and b and c, this term. Okay, so what we are claiming, that we can decompose this term s plus 1 into s square plus 1 into this term. Okay, this a by s plus 1 plus bs by s square plus 1. That means this denominator should be equal and the numerator should be equal. Okay, so just write this term in the multiplication form. We can add these two partial fractions, right? So which will be, in the denominator will be s plus 1 s square plus 1, in the numerator it will be a times this term, that is s square plus 1 plus this expression will be multiplied with this one. Okay, just simple addition of these two partial fraction. Is it clear how you add two terms? Because in the denominator I am multiplying these two terms, in the numerator also I have to multiply this term with this term, right? Is it clear? The simple addition of these two partial fraction. Okay, so then we see that in the denominator these two terms are equal, in the numerator we have to equal this with 1. That means we have to equal all the coefficients. Okay, coefficient with s square will be there, some coefficient with s will be there, and some constant coefficient, we have to equal them with this 1. Okay, so let's simplify this expression in the numerator, which is, okay, a s square plus 1 plus bs plus c into s plus 1. Okay, which will be a square plus a plus b square plus bs plus cs plus 1. Okay, just collect all the coefficients which are common to a square, which is a plus b square, again coefficient which are common to s, which will be b plus cs plus, and constant term, this is c, right, a plus c. Okay, and that should be equal to this numerator term, that is 1. That means a plus b should be equal to what? You can see there is no s square term, s term, so a plus b equal to 0. Then only you can equate both terms, right? Similarly, b plus c will be equal to 0 and a plus c will be equal to 1, right? Is it clear? Okay, so again I am repeating. Okay, so what we will do, we decompose this expression, that is 1 by s plus 1 by s square plus 1, this term, okay, you can see, into two simpler term, which is a by s plus 1 bs plus c by s square plus 1. Okay, we have why we have taken bs plus c, because in the denominator we have s square term, right? So this is s square plus 1 term is there. So in the numerator we can have s also or constant term also. Okay, so you can check partial fraction expansion, okay, for this inverse Laplace transform. Okay, that will be also like explain more detail, but I hope you can understand this. This is just simply we want to find some simpler expression. Okay, but this expression in the right hand side will be equal to this term, right? If you just add them simply, that means this numerator coefficient here, that is the a time multiplied s square plus 1 plus bs plus c into s plus 1 will be equal to 1, and the denominator will also be equal, but we see that denominator are already equal, so we have to just equate this numerator to find this coefficient a, b and c. And if we just simply expand this term here, it will be this term, and which should be equal to 1. So that means, because there is no, in this right hand side we can also write like this, right? 0 s square plus 0 s plus 1. That means this 0 should be equal to a plus b, and this 0 should be equal to b plus c, and this 1 should be equal to a plus c. Then you just solve this three equation. Okay, and you can see that a will be half, c will be half, okay, sorry,
B will be minus half.
yeah, yes, so half, a will be half, b will be minus half, c will be half. Okay, you can just solve this simply. That is, for example, you can take the difference of these two terms, so you will be a minus c will equal to 0. Okay, so then do it. Yeah, because of space I am not doing. Okay, let's do it. Okay, so for example, you have a plus b equal to 0 and you have b plus c equal to 0, so you just subtract that, so you have a minus c equal to 0. Then you can add these two equation, a minus c and a plus c, so you have a equal to 2a equal to 1, so a equal to half. Similarly, you can get c equal to half and b equal to minus half. Okay, so we have already done this, you know, all this coefficient we have found. So just write now what we have obtained. Okay, so we have obtained that 1 by s plus 1 s square plus 1 can be written as this expression, right? A by s plus 1 plus bs plus c by s square plus 1, and we have found a equal to half, b equal to minus half, and c equal to half. So we have half time 1 by s plus 1 plus b, I can take half, so it will be minus 1 s. Okay, so just minus s plus 1 by s square plus 1. Okay, again I can just expand, half I can take common, so it is 0.5, 1 by s plus 1 minus s by s square plus 1 plus 1 by s square plus 1. Now we can identify each term and find the inverse Laplace transform, right? So what is the inverse Laplace transform? First term,
e to the power minus c.
Yeah. Second term,
cos t.
Yeah. Third term,
sin t.
Yeah. So this is the answer. Okay, so 0.5 times this one. Okay, is it clear? Okay, so if not clear, you can try or you can ask. Okay, so I think only things that is not clear, that will not be clear, will be the partial fraction, right? How to like decompose this kind of terms into simpler terms. Okay, so please check partial fraction expansion in Laplace transform. You can find there will be like multiple methods how to like find this simpler decomposition. Okay, so then we can move to like next question. Okay, so you have some function is given, and you know initial value theorem, right? So can you find the what will be the f of 0, that is the what is the value of this function at the initial time 0. Okay, now this is question 4. so you can answer then we will discuss. Okay, if something like I'm speeding up, you can also say, okay, I'm just saying very fast. You can also say, I will slowly proceed. Okay. Okay, so very simple question. So we made us discuss this. Okay. So so what is this initial value theorem? First we write. So if you remember initial value and final value theorem, so if f of this is f of t, if the Laplace transform of this is f of s, then the initial value theorem says that this is t goes to 0, that is equal to f of 0, right? This will be same as limit of s f of s goes to infinity, and the final value theorem says that f of t goes to infinity, which is equal to f of infinity, that is the function value at the infinity, is simply s goes to 0 s f of s. Okay, but first we notice that it's not always applicable. Okay, so there is some limitation of this initial value and final value theorem. So what are these limitations there? Okay, so for example, for this function, can we apply this initial value theorem or not? Okay, first see that what is this value at the f of 0. Can anyone say? This is impulse function.
4.
No. Okay, so let me say this. Impulse function is what? Its magnitude is concentration
180.
It's not 1. Okay, let me write this delta t. Okay, so its area is 1. Okay, you can take minus infinity to infinity also. Okay, dt is 1. Okay, delta t is not equal to 1 at t equal to 0. Okay, it's because okay, so so let's first analyze what is this impulse function. Okay, so in the lecture video, if you have noticed, it is just approximation of some signals. Okay, so let it to be minus a to a, then it will be 1 by a, right? A by 2 I'll take. Okay, so then area will be 1. Okay, you see that for this function, if it is considered 0 with a and height 1 by a, then the area will be what? A times 1 by a equal to 1, right? So you take the limit of this when this width goes to 0. That means you decrease this more and more, so this height will increase, right? Because if you decrease a, you take 2 to 0, then 1 by a will be what? It will increase, right? So this impulse function is limit of this. Okay, so you have this function, let denote it to be something, f of we already have f, so g of t which is dependent on a. Okay, some function, so the limit of this function g of this when a goes to 0 is actually your impulse function. Okay, one way of getting impulse function. Okay, there are other ways. So what it means that the width is very narrow, it is only at 0, but its height will be, because if you have width is very small, which is almost 0, then what will be this area? It will be 0, right? So its height has to be infinite. Okay, so it is actually some kind of shock kind of things that is applied for very small duration, but its amplitude is very high. Okay, more like infinity. Okay, so this impulse function means that at the 0 it is actually of very high height. Okay, so at the you can assume it to be like infinity there. Okay, very high value at the 0 for very small duration. So that means this function at the 0, it does not have limit, because this is infinity kind of thing. Okay, so you cannot apply, so one a limitation of initial value theorem is that whenever this impulse is present or the derivative of impulse will be present, we cannot apply initial value theorem. Okay, so let's see what happens if we apply the initial value theorem to this function. Okay, so the Laplace transform of this function will be what then? F of s. What is the Laplace transform of impulse? Okay, 1 and
1.
So this is the Laplace transform of all function, right? Whole function. Impulse is 1 and e to the power 3 e to the power minus t will be 3 by s plus 1. Okay, so if we want to apply the initial value theorem, then that means we take limit of s goes to infinity s f of s, which is equal to limit of s goes to infinity. You see that if I multiply s, it will be s plus 3s by s plus 1, which I can also write as limit of s goes to infinity s plus 3 by 1 plus 1 by s, I can write. Okay, now you see that this goes to infinity when s go, you put infinity, right? But infinity is not something limit. We say that limit exists when it is some finite value. Okay, so it's, we can say that this is infinity. Okay, approximately you can say, but we cannot say, because the limit, we say that it's only defined when this value is finite. Okay, so this initial value theorem is not applicable here. Okay, this is correct answer. So one way to remember is that whenever there is impulse function, or we find the derivative of impulse function, so what will be derivative of impulse function? So what is the Laplace transform of derivative of impulse function? If f of t Laplace transform is f of s, what is the Laplace transform of f of dash t?
S into f of s.
So
minus f of 0.
F of 0. Okay, so here f of 0 is also not defined. Okay, but if you remember in the lecture video, we have this Laplace transform f of t dt. This limit is sometimes taken as what? Can anyone say? 0 minus, right? To take account of this impulse, because the impulse is at the 0 point. Okay, at 0 point its value is infinity, right? But just before the 0, what is this value of impulse? That is no impulse, right? So its value is 0, right? Only at this point its value is very high. So if we take this lower limit to be 0 minus, just to take care of impulse, the formula will be changed to, you can check, it will be just f of 0 minus, right? So it's f of 0 minus, the impulse value just before 0 is 0, so it will be s into f of s, and Laplace transform of impulse is what? 1, so it will be s only, right? So if some expression of this term is also present, like derivative of impulse is there, then its Laplace transform will be what? S, and again you multiply s into f of s, so it will be s square. Again you say that it is unbounded when s goes to infinity. So if impulse function, so just to conclude, what we want to say is that if impulse function is present or derivative of impulse function, so you can compute like any number of derivative of impulse function, right? Laplace transform of that using that derivative formula. You see that you cannot apply initial value theorem. Okay, just to remember that. Okay, so for this function you cannot apply initial value theorem. Okay, so next then we move to another questions, final value theorem. Okay, again, so just check, so you know the final value theorem, so just check whether you can apply this final value theorem, and if not, what is this issue. Okay, so this is question 5. Okay, just answer this question. Okay, the first question is whether this function is bounded or unbounded as t goes to infinity. So unbounded means if it is like going to infinity, or it's remaining to, going to some value which is not infinity. Okay, so let's see. So this function as t goes to infinity, because we want to find this, right? So that means limit of f of t as t goes to infinity, correct? And this f of t is what? 3 e to the power t goes to infinity. And you know that exponential term, what happens if it goes to infinity? Some function, it will be something like that, right? Exponential like this. So it goes to infinity, e to power like very large value of this. So this function is going to infinity. Okay. So let's see what happens if you just apply the final value theorem for this. Okay. Simply f of s is what for this? What will be the f of s for this function? Can anyone say?
3 upon s minus 1.
Correct. Okay. So where is this pole is located for this function? And left hand side, right hand side?
1.
1. So it is in the right hand side, right? So let's just see what happens if we apply this final value theorem. So final value theorem says that this, okay, this f of infinity will be equal to what? Limit s goes to 0 s of f of s, and it's simply limit of s time 3 by s minus 1 where s goes to 0, and it is, you can divide s on both numerator and denominator. It will be 1 by 1 minus s, limit goes to s goes to 0, or simply because it is 0 we don't have to divide, you can just put, and if you put s, so what happened? It is 0, right? Because in the numerator it is s 0 into 3 0, and the denominator is minus 1, so it is just 0. But whether this function is going to 0 or, as we have already seen this function, this 3 e to the power t, it will be just increasing function, right? It will go to infinity as t goes to infinity. Is it clear?
Yes, sir.
So you see that you cannot apply final value theorem here. So when the final value theorem will not be applicable, as you can see this case, as I said, this pole is located in the right hand side. Okay. So if this pole is located in the right hand side, you see that it is already exploding, right? Because this will be unstable, it will represent some unstable system. As you will see in the later classes, it will represent some unstable mode. So this will be increasing, and you cannot apply final value theorem. Okay. So the answer will be, you cannot apply final value theorem. Okay. So again, let's see another problem. Again, the final value theorem. Okay. For this Laplace transform. So let's see, apply and see what will be this final value. Okay, this is question 6. Okay. Okay. Okay, so try to answer this question. So we have you are given Laplace transform of some function. Okay, so you have to find the f of infinity. This is the final value of this function. Okay. Please, can you mute? Okay. Okay, thank you. Yeah. So, okay, the answer through the pole, what will be this value? Again, the question will be whether you can apply final value theorem or not for this. So, can anyone answer?
No, sir, we cannot apply.
Okay, so why you cannot apply?
Expression is going to infinity.
What?
Final value will be infinity.
Okay, so let's see. Okay, so if we apply final value, what will be this value? Okay, let's first assume that okay, you can apply final value and just compute it. Okay, so the final value theorem says that f of infinity equal to limit of s goes to 0 s f of s. Okay, so equal to limit of s goes to 0 and it is s times 3 by s square plus 1, and if you just simply apply, it will be what? 0. You see? Okay, so now see whether it is correct or not. So first find the inverse Laplace transform of this function. So can anyone say what is the inverse Laplace transform of this function?
3 sin t.
Yeah. So, and we are starting from 0. This sine function is what? Like this, bounded between 3 and minus 3. So can you say what will be this function value as it approaches infinity? You see that this function is oscillating, right? And you don't know what is the value of infinity, right? It's as t goes to infinity, also this function will oscillate. So we know for sure that this function value will be between 3 to minus 3, but we don't know what exactly value will be as t goes to infinity, right? But it will be just oscillating function. If some function is like this, you know that as t goes to infinity, it will go to 0. Or some function, you know, like this is going to some constant, you know, it's settling to some value. But for this function, as you can see, its sine function is just oscillating. Its function is bounded, its function value will be definitely between 3 and minus 3, but we don't know as t goes to infinity whether it will converge to one value or not. It will not converge, right? Because it is just oscillating. So there is no single value to which the function will converge as t goes to infinity. So we cannot apply this final value. You see that it's just 0, that is the average of these two numbers, 3 and minus 3. It's not actually, because we don't know that it will go to 0. It will just oscillate between 3 and minus 3. Okay, so you cannot apply again final value theorem for this, as you can see also from this plot in the time domain plot. Okay, so just to summarize when you cannot apply this final value theorem. So as you have already seen in the previous example, if the poles are in the right half domain, that is the here you have this pole was like 1, right? So it is in the right half s plane here, or it in the imaginary axis, as in this case sine. For this sine, it will what? This polar at j and minus j, right? J and minus j is s plane. So you cannot apply final value theorem when the poles are in the right half s plane or in the imaginary axis. Okay, and okay, but you can apply even if it is in the imaginary axis but in the left hand plane. So in that case, what will you get? You will get some damping turn, something like, okay, this pole that it will be in the a plus jb and a minus jb. So what you will get? Some form of e to the at and some sine cos term. Okay, the oscillating term. Even though this is oscillating term, but this damping term will make this function to go to 0. Like, okay, you will get something like oscillating, but it is going to 0. So you see that it will go to 0 or something. Then you can apply final value theorem. So if these poles are in the left hand case, you can apply final value theorem. So one question will be, can you apply final value theorem if there is pole at the 0? It is 0 point, that is the 1 by s term. Can anyone answer? A single pole is there. Okay, so what is the inverse Laplace transform of 1 by s?
1.
Yeah, 1 or ut you can write also, right? Unit step function that is starting from 0. So what is the final value of this u of infinity? from this diagram, can you say?
1.
Huh.
Oh,
Yeah. So you can apply there. Okay, you can just check. This is the s f of s, which will be what? S into 1 by s, right? 1. So limit of this s goes to 0 will be what? 1 only, right? But if there are multiple poles are there, can you apply? Multiple poles are at the 0. Just whatever you think, just answer. We'll see whether it is correct or not. Don't think that much, okay? What do you believe?
So I think we cannot apply.
Yeah.
If more poles are
Yeah.
presented.
Okay, so why? Can you say? Okay, just see. A multiple poles it is 0 means.
Sorry, sir.
Yeah, like 1 by s square. So what is the inverse Laplace transform of that?
T.
Yeah. So as t goes to infinity, what will happen? This value, it will also go to infinity, right? And we say that infinity is not a limit. Okay, limit means it should be a finite value. So you cannot apply. Okay. So if there are multiple poles, similarly you see that if SQ or something, then you will see some t square or some power, right? So it will be unbounded signals. Only single pole will be there, then it is just a constant term at the 1. Okay. So you cannot apply final value theorem for these cases. Okay. When there are poles in the right hand side or imaginary axis or multiple poles in the 0, you cannot apply final value theorem. Okay. So this is one of the above. Okay. Okay, so next question. So very simple question. So you have to find DC gain. Okay, this is question 7. Okay. Okay, so we can answer through the poll.
It's 0.4.
Yeah, okay. So yeah, very simple question. So you find the DC gains means s goes to 0. So that is just 2 by s. Okay, when limit you take the s goes to 0. 2 by 5. So it is 0.4. Yeah, DC gain. So just direct question. Okay, so then we move to next question. Okay. So for the transfer function of this network, okay. So that is the V out which is taken across this C2 capacitor and this input voltage which is V in. So we have to find the Laplace transform of V out by V in with all this initial condition being 0. Okay, this is question 8. Okay. So the first question, can you apply the cascade formula for this network? Like you know
Yes,
that,
sir.
huh?
Yes, sir.
Okay, can you apply, like what is the limitation of applying that cascade, right? Whenever these two blocks are there in the cascade, you have the transfer function, just the multiplication of these two, right? Whether you can apply for this or not, like you have two individual blocks, you can see.
No, sir.
Okay. So why you cannot apply?
So gain between two should be 0.
Sorry. If you remember, there is loading effect, right? If some power is drawn, that means that one circuit will be, when you connect them to circuit, the behavior will be different, right? That means you have two blocks here, this block and this block. Okay, this RC block. How they behave individually is different. How they behave when they are interconnected. If there is some effect, that is the, because the current will be drawn from this, right? One current will be, let it be I1 and this will be I2. This current I2 and I1, some current will be flowing this C, right? And some current will be flowing that. So their behavior is changed when they are separate and when they are interconnected. So there is some power loading effect is there. So this loading effect will make you to think this as a single circuit, not as an individual circuit. Okay, so you analyze this as a single circuit. How you analyze, then you can find the transfer function. Okay, if there is some kind of amplifier is present which actually avoid this loading effect, so amplifier with a unit gain, there will be no loading effect, then you can just simply apply the cascade formula. Okay, so just try. Okay, so okay, so simply just write this KVL and then eliminate this current, whatever that current is not necessary. Then you will find this transfer function V out by V in. Okay, you can just work in the Laplace domain directly. Okay, so just Laplace domain, this will be R and this capacitance will be, the impedance will be C1S, this will be 1 by C2S, Laplace transform of this, because this is the integral of this current, right? 1 by C1 integral of current, whatever current is flowing through that, and you know that Laplace transform of integration is, what is this Laplace? Huh? Okay, can you please mute? Okay, can you please mute? Okay, so okay, so you know that Laplace transform of integration is what function? Some C
1 by CS.
so it will be as CSI, right? Laplace transform of this. Okay, so you just try this directly working on the, you can directly work in the Laplace domain. Okay, you just replace whenever this R is present, this is just R because the I is just simply multiplying with it. Whenever capacitor is present, you take 1 by C integration of I, so it will be 1 by C1S into IS, right? And when the inductor will present, it will be L di by dt, and derivative you know S times of IS, so it will be S into inductor value L if there is no initial condition, or if there is some initial value, so you just subtract that. Okay, so in short, you can replace all this resistance, capacitance and inductance as an impedance in the frequency domain as resistance simply as R, capacitance by taking as a 1 y reciprocal of S times that capacitance value, and the inductance as S times that inductance value. Okay, so because there is no inductance, so we don't need, but okay. Okay, so okay, so just let's write this. Okay, so take two currents, let I1 and this way I2. Okay, so I just write in the frequency domain directly. You can also write in the time domain and then take the Laplace transform. Okay, so this will be R in the frequency domain, it will be V in S, that is the Laplace transform of V in, this will be V out S, so I am just omitting S. Okay, so simplifying, this I will be capital I1 S and this current will be I2 S, and the resistance will be R1 R2, and this C1 will be 1 by C1 S and this will be 1 by C2 S. Okay, is it clear? Or if not, simply write this expression in the time domain and then take the Laplace transform. Okay, that will also I'll do that. Okay, so in the time domain, if this is I1 and this is I2, what will be this in time domain? R1 I1 plus 1 by C1 integration of I1 dt minus 1 by C1, this current is flowing in this direction I2, so I have minus sign, equal to V in. And second equation will be minus 1 by C1 I1 dt plus 1 by C1 I2 dt plus R2 I2 plus 1 by C2 I2 dt equal to 0. Second loop. Okay. We take the Laplace transform of both equation. Then it will be first equation will be what? Let Laplace transform of I1 be I1 capital, I am denoting without s, okay, just for simplifying, and I2 be I2, okay, small I2 be I2 Laplace transform. Then from first expression we have R1 plus 1 by C1 s I1 minus 1 by C1 s I2 equal to V in. Okay, the Laplace transform I am denoting with capital letter. Okay, from second expression it is Laplace transform of second expression, it will be minus 1 by C1 s I1 plus this is R2 plus 1 by C1 s plus 1 by C2 s I2 equal to 0. Okay, so we want to find V out by V in, and you can see that V out, what is this V out? V out is simply this voltage across this capacitor C2, so which is V out equal to small V out equal to 1 by C2 integral of I2 dt. Okay, or capital V out, that is the Laplace transform will be what? 1 by C2 s I2. Okay, so if we know I2 in terms of V in, then we can simply find V out in terms of V in, and then just take the ratio V out by V in to find the transfer function. Okay, so we have to eliminate I1 then, and you can see from second expression you can find I1 in terms of I2, right? So which is, I'll write here. Okay, so minus, so I am taking other side, so it is just plus, so I1 1 by C1 s equal to, we have R2, this is R2 or R1? Okay, I am written R2, right? Oh, sorry, R2 C1 C2 s plus C1 plus C2 by C1 C2 s. Okay, I2 from this expression I am getting this. So I2 equal to, then sorry, I1 equal to, then we have just C1, we divide this. Okay, so I1 equal to, then we have R2 C1 C2 s plus C1 plus C2 by this C1 s will cancel, so we have by C2 I2, and we put this in the first expression, this expression. Okay, I am denoting it to star, this star expression. Okay, so we have R1, this term I can write R1 C1 s by C1 s, right? So I have R1 C1 s plus 1 by C1 s. Just simple manipulation. Okay, nothing. And I1, instead of I1 here I can put this expression, this one, R2 C1 C2 s plus C1 plus C2 by C2 I2, and this expression, okay, this here also minus 1 by C1 s I2 equal to V in. Okay, then you just simplify this expression. So we multiply this and subtract this 1 by CS I2, you can take common, so you have R1 C1 square C2 s square C1 C2, okay, sorry, R1 R2 C1 square C2 s plus R1 C1 square s plus R1 C1 C2 s plus R2 C1 C2 s plus C1 plus C2, and for this term it will be minus C1, right? C2, sorry, C2, because C1 in the denominator, above will be C2, this term, by c1 c2s. Okay, this I2 multiplied with I2 equal to V in. You can cancel this C2 and you can take C1 common and can cancel out. Okay, so from each term you can take C1 common and cancel out with this term, so it will be R1. okay, I don't have space here, I have to write. Okay, R1 R2 C1 C2 S square, this is S square plus R1 C1 plus R1 C2 plus R2 C2 S plus 1 by C2S I2 equal to V in. Okay, but we know that I2 by C2S what? Here I2 by C2S V out, right? So this whole expression can be written as one. This I2 by C2S, this term can be written as V2 V out. Okay, so then V out by V in is just reciprocal of this term, 1 by R1 R2 C1 C2 S square plus R1 C1 R2 C2 R2 C2 R1 C2 R2 C2 S plus 1. Okay, so you can check, this is D, right? Yeah. Okay, just you have to just compute this. Okay, just lengthy computation, nothing else. You just apply this KVL and then simplify. Okay, nothing else is there. Okay, so next will be, okay, so for this expression, okay, we already have this expression, I'm just writing that here. R1 R2 C1 C2 S square plus R1 C1 plus R2 C2 plus R1 C2, okay, S plus 1. So this is the transfer function we get. So if these are the values, then what will be the poles? Okay, you can just simple put and compute this, nothing else is there. Question 9. And you can check whether these poles are like, what kind of poles are there, like whether they are in the right, left hand side, repeated or something like that. Okay, okay, so the simple question, so you can just proceed with this, nothing else. If you take R1 R2 C1 C2 to be like 1, then this transform into transfer function will be S square plus this 3 terms are there 1, so 3S plus 1. Okay, and we can check the discriminant of this, that is the B square minus 4AC, right? If it is positive, then poles are, real poles are present, and they will be like different of each other, right? Or you can simply just take this, in a calculator you can check where these poles are there. Okay, you can check, and this will be some distinct negative poles. Okay, you can check, verify this, some value will come, negative value will come. Okay, so this is negative and distinct root. Okay, so next question will be, okay, Laplace transform of some signal. Okay, so find this Laplace transform of this signal. So one signal is given, so okay, so can anyone suggest how to proceed for this problem? Okay, so one hint will be, you can see like it's a combination of some simple function, right? So what are these simple function? Can anyone say? Like you
2 times ut t.
So you can see some step function, some kind of ramp function, that is the linearly varying function. So can you express this as a summation of some function, some simple function, that is the unit step function, and some ramp function? Then you can find the Laplace transform. Okay, so one formula we will use for that is, if f of t Laplace transform is f of s, f of t minus some that t is there, u t minus tau. So Laplace transform is minus st. Okay, so f is there, f of this. So this yes, f of s. Okay. 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 Question can you see this question in the okay, yeah, so okay, just try this. Okay, so yeah, so this is the shifting of this. Okay, so you shift the function t minus t. So what this mean also, you shift the function by t and multiplying this u t minus t, what will happen? So can you say, can anyone say what is this unit step function at t minus t? So where this function will start? Okay,
From t.
yeah, so this is ut, right? Ut function which is 0 before t equal to 0, and it will be 1 at t. And if I write it some function like u t minus t, where t is capital T is some positive number here, that means I shifted this unit step function up to t. Okay, this will be 1 and this. Why? As you can see that for ut function, this function value start whenever this argument is 0, right? And for this function, the argument will be 0 when t equal to t, right? T minus t will be 0, so it will shift it to t times and it will start from there. So multiplying this means that this function value will be 0 before t, and this function will start only after t. Okay, ut t minus t. Okay, multiplying that. And why we will do, it will be clear. Okay, so let's just discuss this problem, then it will be clear. Okay, so we'll do by two approach. Okay, both approaches are very similar, and you just see which approach will be like convenient for you. Okay, so first we write this function. As you can see, there is some step as well as a ramp function are there. So can we write like some summation of some simple function, because we know Laplace transform of unit step function as well as ramp function. Ramp function means t, like, so Laplace transform of unit step ut is step function is what, 1 by s, and t is 1 by s square. So we can apply that, and we also can apply this formula. Okay, Laplace transform of this, whenever it is multiplied by f of t minus t shifted, it will be e to power minus st f of s. Okay, we'll use this formula. So first write this signal whatever given as a sum of some simple function. Okay, step function and ramp function, and see whether we can write. Okay, so let's analyze this signal. So at this 0 we have a step function which is of height 2. Okay, so we have like this step function height 2, ut multiplied with 2. Okay, but we see that at t equal to t time capital T, its function is not like this. Okay, so what function we have to add at t to make it minus 2?
-4
Yeah,
ut minus.
yeah. So we have to add some at t. We can add some -4 here. So we can add one function -4 ut, and you see that this function, addition of these two function will be what? This will be like this, and then it will be like this, right? Okay, I will use some color, then it will be this red one. This will be the summation of this function, that is 2 ut minus 4 ut. But this function is also it similar up to this, but not up to after that, right? So you have to add another ramp function to make it like that. So if you add some ramp function like that, then it will be this red one. I'm using this green one again. This signal will be like that. Okay, it will just go like. So what is this ramp function? What is the slope of this ramp function? Okay, Hindi. Okay, I don't know, because student is comfortable with Hindi. Somebody is asking.
Yes, sir.
Okay, so okay, then I will say okay. So this स्लॉप कितना स्लॉप है उसका? ओके, सो तुमको देखना पड़ेगा यहाँ पर। देखो इस ए फंक्शन जो रैम्प फंक्शन है, जो लिनियरली वेरी कर रहा है, उसका स्लॉप कितना है? कैन एनीवन आंसर? टी, राइट? 1/t, because the slope will be this height by this, whatever change this is happened in the time duration, so it is 2/2t. So it is 1/t. So you see that you have to okay, तुमको एक ऐड करना पड़ेगा, एक रैम्प फंक्शन ऑफ स्लोप 1/t स्टार्ट, जो स्टार्ट हो रहा है तुम्हारा t से। सो कैसे लिखोगे तब? कैन एनीवन से? ओके, सो फंक्शन स्टार्ट हो रहा है टी से, सो तुमको ऐसे लिखना पड़ेगा, स्लोप है उसका टी। सो नॉर्मल फंक्शन कैसे होगा? टी, राइट? और स्लोप मल्टीप्लाई करोगे उसके साथ जो भी रैम्प सिग्नल है। क्लियर है? सोचो कि स्लोप 3 है तो ये फंक्शन क्या होगा? 3t होगा। स्लोप 2 है तो फंक्शन कैसे करोगे? 2t, ऐसे, जिसका स्लोप मल्टीप्लाई विथ टाइम, राइट? क्लियर है? हाँ, ओके। सो तुमको ये स्लोप तो तुम्हारा कितना है? 1/t। तो तुम मल्टीप्लाई करोगे उसके साथ आर्गुमेंट, जो फंक्शन t था अभी, लेकिन फंक्शन शिफ्टेड है। ये जो रैम्प फंक्शन है स्टार्ट कहाँ पे हो रहा है? t पे, तो उसको शिफ्ट करोगे t के अमाउंट के साथ। ओके, बट ये शिफ्ट करोगे तो ये फंक्शन ऐसे भी रहेगा ना, पीछे भी, तो पीछे वाला पर्सन तुमको नहीं चाहिए, इसको 0 करना है। तो कैसे करोगे? एक यूनिट स्टेप फंक्शन मल्टीप्लाई करके, क्योंकि यूनिट स्टेप फंक्शन बिफोर t इट विल बी 0, राइट? इसका वैल्यू 0 होगा, तो ओनली आफ्टर t ए वैल्यू 1 होगा। तो ये क्लियर है? तो इस फंक्शन कैसा रहेगा? देखो अभी t पे स्टार्ट कर रहा हूँ, तो t इक्वल टू ओके, सो ये क्लियर है?
यस सर।
हाँ, ओके। सो तुमको ऐड करना पड़ेगा यहाँ पे एक फंक्शन। ओके, सो ये फंक्शन एक्चुअली स्टार्ट हो रहा है यहाँ से 0 से। ओके, ये वाला रैम्प जो ऐड कर रहे हो 0 से, तुम देख सकते हो t इक्वल टू टी टाइम्स ये वैल्यू 0 होगा, और ये फंक्शन का वैल्यू बिफोर 0 होगा, क्योंकि यूनिट स्टेप मल्टीप्लाई हुआ है। ओके, अगर क्लियर नहीं है तो पूछ लेना। ओके, सो अभी ये वाला ऐड कर दिया, लेकिन अभी देखो 3t पे हमको सब सिग्नल 0 लाना है, तो हम क्या करेंगे? और एक रैम्प फंक्शन सब्सट्रैक्ट करेंगे, जो सेम स्लोप होगा t। स्टार्ट कहाँ पे होगा
सर? 3t पर सर।
हाँ, और उसको ये फंक्शन जो ऐड करेंगे हम, उसको ये सब्सट्रैक्ट करेंगे, वो 3t से पहले उस फंक्शन का वैल्यू कितना होना चाहिए?
थ्री टी से सर -2 सर
नहीं
+2 सर -2 इसमें सर
ओके ओके सो
क्या सर?
मैं फिर से एक्सप्लेन कर रहा हूँ। देखो, हम लिख रहे हैं एक
हाँ
फंक्शन को समेशन एज फंक्शन, ओके समेशन ऑफ फंक्शन लिख रहे हैं। हम एक 2t फंक्शन स्टार्ट किए यहाँ से यूनिट स्टेप, फिर ऐड किया एक यूनिट स्टेप यहाँ पे t टाइम पे -4ut, फिर एक रैम्प फंक्शन ऐड किया t टाइम पे, बट ये रैम्प फंक्शन पहले नहीं था, ये पहले नहीं है t से पहले। ओके, सिमिलरली 3t से पहले वो रैम्प फंक्शन जो हम सब्सट्रैक्ट करेंगे इस तरह से एक फंक्शन, वो नहीं होगा। तो इसके लिए हम क्या करेंगे, यूनिट स्टेप फंक्शन फिर यूज करेंगे। ओके ओके, ये वाला अप्रोच देख लो, फिर दूसरा अप्रोच मैं यूज करूँगा, उसमें मैं भी क्लियर होगा थोड़ा। तो ये एक्चुअली ओरिजिनल फंक्शन है तुम्हारा ft। ओके, सो फिर से लिखते हैं वो फंक्शन क्या था क्लियरली यहाँ पे। ओके, तो हम यहाँ पे एक यूनिट स्टेप 2 हाइट का ऐड किए थे, उसके बाद सब्सट्रैक्ट किए थे t टाइम पे 4 हाइट का। ओके, सो 2 2 -4 -2 हो जाएगा। फिर हमने एक ऐड किया रैम्प ऑल्सो यहाँ पे, जो t से स्टार्ट हो रहा है, सो इसके लिए हम यूनिट स्टेप t मल्टीप्लाई किया t -t, स्लोप उसका t है। फिर यहाँ पे सब सिग्नल 0 है, तो यहाँ पे हम सब्सट्रैक्ट करेंगे सेम सिग्नल रैम्प, बट वो स्टार्ट हो रहा है कहाँ से, 3t से, जिसका स्लोप t है, और स्टार्ट हो रहा है, तो इसको हम इस तरह से लिखेंगे क्योंकि उससे पहले वो नहीं था। ओके, ये हो गया तुम्हारा पूरा सिग्नल। अभी उसका बस लाप्लास ट्रांसफर लिखना है। तो लाप्लास ट्रांसफर कितना होगा, 2 टाइम्स इसका ut का 1 है, 1 है, इसका 2 कॉमन लिया हूँ और 2 है सॉरी इसको, ये स्टार्ट हुआ था तुम्हारा -t से, राइट, ये वाला, हाँ -t st। ओके, उसके बाद लाप्लास ट्रांसफॉर्म ऑफ दिस, ये फंक्शन का क्या होगा, यहाँ पे मैं लिखा था फार्मूला f(t - t ut - t e−st f(s)। ओके, सो अगर t नहीं होता तो ये क्या फंक्शन है, बस t है, राइट, t कॉन्स्टेंट वैल्यू है, सो 1/t तुम कॉमन ले सकते हो यहाँ पे। उसके बाद t का क्या है, s² है। ओके, अभी -t है यहाँ पे, तो ये फंक्शन कितना है, e−st होगा। ओके, सिमिलरली इसका कितना होगा, सेम रहेगा, बस -3st होगा। क्लियर है, ये प्लस था, सॉरी। तो तुम्हारा आंसर कौन सा था, सी वाला। ओके ओके, सो अगर ये अप्रोच डिफिकल्ट लग रहा है तो दूसरा एक अप्रोच हम देखते हैं, ठीक है। वो सेम ही है, बस डिफरेंट क्या है कि तुमको यहाँ पे थोड़ा सा रिप्रेजेंट करना पड़ेगा। तो अनदर अप्रोच विल बी, और दूसरा अप्रोच क्या है, देखो एक यूनिट स्टेप है जो 0 पे स्टार्ट हुआ और t पे ख़त्म हो गया, ठीक है। और तुमको दूसरा एक फंक्शन लिखना पड़ेगा,
रैम्प फंक्शन लेकर सब सब्ट्रैक्ट कर दें।
हाँ हाँ, तो रैम्प फंक्शन जो है ये वाला फंक्शन, ओके, तो ये वाला फंक्शन तुमको लिखना पड़ेगा जो तुम ऐड किया, सब्सट्रैक्ट किया। ओके, यहाँ से स्टार्ट हो रहा है, तुम ऐसे एज्यूम कर सकते हो रैम्प। ओके, तो इसका स्लोप वही 1/t है, तो स्टार्ट हो रहा है, मतलब स्टार्ट नहीं, मतलब यहाँ पे पास कर रहा है 0 पे, वो वाला तुमने ऐड किया यहाँ पे और सब्सट्रैक्ट किया। ओके, तो तुम ऐसे भी लिख सकते हो। तो एक यूनिट स्टेप फंक्शन है, ओके, 2 टाइम्स ऑफ दिस, तुमने इसको यहाँ पे ऐड किया था, फिर इसको सब्सट्रैक्ट किया, यहाँ से 0 आ गया, तो t माइनस ये कैपिटल T था यहाँ पे, ये वाला फर्स्ट पार्ट, ये वाला ब्लॉक, बस क्लियर है ये। तो क्या है, यूनिट स्टेप यहाँ पे बस इतना तक है ना, तो यहाँ पे ut था, 2ut जो है 2 बाहर लिखा है मैंने, उसके बाद तुम बस सब्सट्रैक्ट कर दिया, तो यहाँ पे अभी हो तुम, और एक रैम्प सिग्नल है इसको। ओके, उसके बाद ऐड किया, लेकिन यहाँ के बाद नहीं है वो रैम्प सिग्नल। ओके, तो ये रैम्प सिग्नल क्या था, स्लोप हम पहले निकाल चुके थे 1/t, जो पास कर रहा है 3t के 0 में, तो उसका वैल्यू क्या होगा, ये क्लियर है। इस रैम्प सिग्नल अगर लिखोगे, रैम्प सिग्नल कैसे होगा, देखो वो 3t पे उसका वैल्यू कितना है, 0, जो 0 पे पास कर रहा है, और उसका स्लोप कितना है, ये 2 है, ये 2t है, t से 3t। ओके, तो स्लोप है 2/2t इक्वल टू 1/t। ये क्लियर है? ओके, फिर से मैं एक्सप्लेन कर रहा हूँ अगर क्लियर नहीं है, देखो। ओके, सो फर्स्ट हम ये यूनिट स्टेप के लिए लिखेंगे, जो ये बॉक्स है, ये बॉक्स। ओके, बस इतना बॉक्स के लिए सिग्नल जो है, तो सिग्नल क्या होगा, ये सिग्नल था तुम्हारा, यहाँ पे स्टार्ट हुआ, अभी यहाँ पे ख़त्म हो गया, कहाँ पे हो गया वो, टी पे। तो तुम सेम सिग्नल सबस्ट्रैक्ट करोगे, लेकिन वो टी पे सिग्नल सबस्ट्रैक्ट करोगे। ओके, अभी ये जो रैप सिग्नल था यहाँ पे, वो वाला सिग्नल क्या है, 3t पे पास कर रहा है, तो t-3t जहाँ पे 0 है, उसका स्लोप क्या है, t। ओके, कहाँ, क्लियर है, कहाँ पे स्टार्ट हुआ है, कहाँ पे खत्म हुआ है ये,
टी पर सर स्टार्ट और 3D पर खत्म होगा।
हाँ, तो तुमको ये लिखना है, ये क्लियर है, क्योंकि इसका वैल्यू 1 होगा t के बाद, ठीक है, ऐसा है, t है, अभी ये वाला फंक्शन 1 है यहाँ पे, ये ठीक है, और ये चलेगा, ये वाला फंक्शन कहाँ से स्टार्ट होगा, 3t से, इसका वैल्यू 1 है, जो तुम सबस्ट्रैक्ट कर रहे हो, तो सबस्ट्रैक्ट करने के बाद क्या हो जाएगा, 1 - 1 0 हो जाएगा, राइट। तो तुम क्या कर रहे हो, ये टर्म को मल्टीप्लाई करो इस फंक्शन के साथ, तो इस रेंज में t से 3t में ये मल्टीप्लाई हुआ कितना वैल्यू, 1 के साथ, 3t के बाद ये कितने के वैल्यू के साथ मल्टीप्लाई हो रहा है, 0 के साथ, राइट। ये वाला पार्ट क्लियर है, फिर से,
यस सर।
हाँ, तो ये फंक्शन ऐसे भी लिख सकते हो, ठीक है। तो अभी प्रॉब्लम क्या है, देखो यहाँ पे तुम लाप्लास ट्रांसफॉर्म जो अप्लाई करोगे, यहाँ पे देखो ये t-3t है, यहाँ पे t-t है। ओके, सो फॉर्मूला देखने जाओगे तो यहाँ पे मैं लिखा था ये, इसके जगह t का ये जो सेम कोएफिशिएंट यहाँ पे सबस्ट्रैक्ट होना चाहिए, f(t) पे जो है ये t हो सकता है, और कोई मतलब अल्फा टाइम t भी हो सकता है, लेकिन ये फॉर्मूला हमेशा t-t u सेम शिफ्ट होना चाहिए बोथ में, ठीक है। लेकिन यहाँ पे क्या है, देखो यहाँ पे 3t है, यहाँ पे t है, तो इसको तुमको सेम चीज़ में लाना पड़ेगा, ठीक है। उसके लिए क्या करोगे, सिंपली t-3t को भी तुम ऐसे लिख सकते हो, t-2t लिख सकता हूँ, ठीक है। तो फर्स्ट टर्म क्या रहेगा, 2ut जो रहे वो ऐसा रहेगा, सेकेंड टर्म के लिए मैं क्या लिखूँगा, t-2t ओके, बाई t मल्टीप्लाई करूँगा मैं इसके साथ t-3। ओके, तो मैं सेपरेट कर देता हूँ, इसमें इजी होगा। इसके साथ जो मल्टीप्लाई है उसको मैं चेंज करूँगा पहला टर्म के साथ, दूसरा टर्म के साथ मेरे को चेंज करने का ज़रूरत नहीं है, क्योंकि वो सेम कोएफिशिएंट है। ओके, तो ये रहेगा बस t-3t, जस्ट एक्सपांड कर रहा हूँ सेकेंड टर्म को, ओके, बाई t-3t, क्योंकि ये सेकेंड टर्म सेम है, राइट, ये माइनस होगा, सॉरी, सेकेंड टर्म सेम है, 3t है, तो मेरे को वहाँ पे चेंज करने का ज़रूरत नहीं है, पहला टर्म के लिए चेंज करना पड़ेगा, जैसे t-2t। ओके, तो यहाँ पे मैं लिख रहा हूँ फिर से वो, तो पहला टर्म क्या था, 2ut - t, जो फर्स्ट टर्म था ये वाला वो वैसे ही है। सेकेंड टर्म में t - के साथ पहले मल्टीप्लाई था ये, तो ये हमारा प्लस t - बाई t एक टर्म है, और दूसरा एक -2t कैंसिल हो जाएगा, -2 रहेगा, सो ये रहेगा -2u ओके। और थर्ड टर्म जो है वैसा रहेगा, -t - 3t बाई tu ओके। ये क्लियर है, हम क्यों कर रहे हैं वो भी क्लियर है, इसको क्यों हम सेपरेट किए, क्योंकि ये आर्गूमेंट -t है, तो हमको भी -t चाहिए वहाँ पे फंक्शन में, जो अभी इस आर्गूमेंट में, ये वाला आर्गूमेंट जो देखोगे तुम, ओके, ठीक है। अभी क्या करोगे, ये वाला टर्म यहाँ पे तुम ऐड कर सकते हो, तो वो क्या है, 2ut माइनस 2ut माइनस टी, ओके, प्लस t माइनस टी बाई टी, ये एक तुम्हारा टर्म है u t माइनस टी, और ये लास्ट टर्म है, ये वाला मैंने ये वाला टर्म यहाँ पे ऐड किया है, ओके। तो तुम्हारा ये कितना है, सॉरी, ये एक टर्म है, और t माइनस 3t बाई टी u t माइनस 3t। अभी तुम अगेन लाप्लास ट्रांसफॉर्म डालोगे जैसे डाला था फॉर्मूला, तो पहला टर्म का क्या होगा, 2 1 माइनस ई टू पावर माइनस एस टी, इस टर्म का, बिकॉज ये तुम्हारा रैम्प फंक्शन है तो ये है स्क्वायर रहेगा टी, और शिफ्टेड है, फर्स्ट टर्म शिफ्टेड है माइनस टी पे एस टी, सेकेंड टर्म है माइनस 3t पे माइनस हो, ओके, सेम आंसर मिलेगा, ओके। क्लियर है ये, या फिर कोई पे डाउट है? ओके, जो यहाँ पे बस याद रखना है कि तुमको सेम आर्गुमेंट लाना है, इसीलिए तुमको, हाँ,
Laplace of unit function will be
सॉरी एस होगा ना, हाँ सॉरी, करेक्ट, और 2/s, हाँ, मैं यहाँ पे लिखा था क्या,
सर एक बार फिर से लाप्लास कैसे कर रहे बता दो।
हाँ हाँ, अच्छा ठीक है, मैं फिर से एक्सप्लेन कर रहा हूँ, ठीक है। पहला वाला पार्ट क्लियर है ना, बस लाप्लास ट्रांसफर निकालना है, हाँ, मतलब कैसे सिग्नल लिखा
हाँ,
गया, हाँ लिखा गया वो क्लियर है, बस लाप्लास ट्रांसफर दिखाना है,
वो भी है।
हाँ ठीक है।
हाँ।
तो ये एक फॉर्मूला है, एफ ऑफ टी माइनस, हम सोचो कि कैपिटल टी है, और एस मैंने और भी यूज करता हूँ, एफ ऑफ टी माइनस सोचो अल्फा टाइम टी है, यू टी माइनस अल्फा टाइम टी है, तो इसका लाप्लास ट्रांसफॉर्म क्या है, ये है, ठीक है। यहाँ पे एफ ऑफ एस लाप्लास ट्रांसफॉर्म एफ ऑफ टी है, ठीक है, ये फॉर्मूला चेक कर सकते हो, और तुम डिराइव भी कर सकते हो, कोई प्रॉब्लम नहीं है, इसको सिंपल है, मैं दिखा रहा हूँ कैसे है। देखो, एफ ऑफ लाप्लास ट्रांसफॉर्म, इसका मतलब है तुमको अल्फा टी यू टी माइनस अल्फा टी ई टू पावर माइनस एस टी डी टी, राइट, ये है लाप्लास ट्रांसफॉर्म फॉर्मूला। यहाँ पे मैं एफ ऑफ टी की जगह ये फंक्शन लिखा हूँ, मतलब लाप्लास ट्रांसफॉर्म एफ ऑफ टी कितना होता है, एफ ऑफ टी ई टू पावर माइनस एस टी डी टी, राइट, तो इसकी जगह ये लिखा हूँ फंक्शन। लेकिन यूनिट स्टेप ये कहाँ से स्टार्ट होगा, माइनस अल्फा टी से, सो ये फंक्शन जीरो है बिफोर, तो तुम लिमिट ऐसे भी लिख सकते हो, क्योंकि फंक्शन वैल्यू जीरो है बिफोर, तो ये है एफ ऑफ टी माइनस अल्फा टी, ये 1 हो जाएगा, ये ई टू पावर माइनस एस टी डी टी। तो अभी जब चेंज ऑफ कोऑर्डिनेट करोगे, टी माइनस अल्फा टी की जगह टाउ लिखोगे, तो ये लिमिट हो जाएगा 0 टू इन्फिनिटी एफ ऑफ टाउ ई टू पावर माइनस एस टी, और एक टर्म आएगा ई टू पावर एस टाउ का, सो अल्फा टाउ का, सो तुम बाहर ले सकते हो अल्फा, सॉरी टाउ टी कैपिटल टी, ओके, तुम बस चेक कर सकते हो, तो डी टी डी टाउ, अभी मैंने लिमिट चेंज किया है, तो इसका लाप्लास ट्रांसफॉर्म एफ ऑफ एस है, सो इट इज ई टू पावर माइनस अल्फा टाउ एफ ऑफ एस है, जो कि ये फॉर्मूला कहता है, ठीक है। तो इन शॉर्ट लाप्लास ट्रांसफॉर्म ऑफ दिस फंक्शन ये है। तो हमको क्या मिला था पहले, 2 टाइम्स ऑफ यू टी माइनस यू टी माइनस टी, यहाँ पे 2 था मल्टीप्लाई, प्लस टी माइनस टी और कैपिटल टी यू टी माइनस टी माइनस टी माइनस 3t कैपिटल टी यू टी माइनस 3t, ये था सिग्नल का एक्सप्रेशन, राइट। अभी तुमको बस लाप्लास ट्रांसफॉर्म इंडिविजुअल टर्म में निकालना पड़ेगा। तो ये फर्स्ट टर्म का क्या होगा, 2/s, इसका क्या होगा -4/, कोई बोल सकता है क्या होगा?
4/s e⁻⁻s।
हाँ, थर्ड टर्म का ये वाला एक्सप्रेशन यूज करो। यहाँ पे टी का जगह वो फंक्शन है टी का क्या है? 1/t तो कांस्टेंट है। टी का लाप्लास ट्रांसफॉर्म क्या है?
1/s²।
हाँ, तो ये है एफ ऑफ टी के जगह यहाँ पे क्या है? ओके, एफ ऑफ टी अगर तुम टी लोगे
e⁻⁻st।
हाँ ठीक है, क्योंकि ये शिफ्ट हुआ है कितना -t को, ये फॉर्मूला के साथ कंपेयर करो, अल्फा = 1 है अगर, तो e⁻⁻t एफ ऑफ एस क्या है? 1/s², राइट। टी तो कांस्टेंट है, कैपिटल टी, ओके। 1/t वो पहले ले लिया कॉमन, ऐसा लिखता हूँ अच्छे से, तो 1/t कॉमन ले लिया। अभी जो बाकी है ये फंक्शन है t के बदले ये एफ ऑफ टी माइनस अल्फा टी है, शिफ्टेड वर्सन, ठीक है। t का हाँ ठीक है, तो t का ये है 1/s², और इस शिफ्ट के लिए ये मल्टीप्लाई करोगे तो e⁻⁻st। लास्ट टर्म का क्या होगा, कोई बोल सकता है?
e⁻³
ठीक है, क्लियर है अभी?
1/s होगा ना सर? 1/s ना होगा?
s² होगा ना। ये फंक्शन क्या है, ये किसका शिफ्टेड वर्सन फंक्शन है?
अच्छा, हाँ ठीक है,
हाँ,
टी है सर, हाँ
हाँ
सर,
हाँ
ठीक।
हाँ, तो थोड़ा चेक करना पड़ेगा अच्छे से, ठीक है। ये टी अगर फंक्शन है तो इसको हमने लिखा है t-3t, जो फंक्शन एफ ऑफ टी था इक्वल टू टी था, तो हमने लिखा है क्या, एफ ऑफ टी माइनस दिस इंटू दिस, सो इट इज ये है जो कि ये टर्म है, राइट। 1/t तो कांस्टेंट है, इसको ये करना, ठीक है। अभी क्लियर है, कोई डाउट है?
यस सर, यस सर,
हाँ
क्लियर।
हाँ, तो अच्छे से वहाँ पे चेक करना है कि फंक्शन क्या है, ठीक है। यहाँ पे फंक्शन क्या था, 1 था, राइट। 1 मल्टीप्लाइड विथ 1 का लाप्लास ट्रांसफॉर्म क्या है?
1/s।
हाँ ठीक है, तो ठीक है, फिर से देख लेना सब प्रॉब्लम, ठीक है। मैं शायद दे दूंगा प्रॉब्लम उनको, फिर से प्रैक्टिस कर लेना कुछ कुछ, तो क्लियर हो जाएगा।
ठीक है सर।
हाँ ठीक है, कोई और क्वेश्चन है? ओके, सो कोई क्वेश्चन नहीं तो ठीक है, हम फिर से मिलेंगे, ठीक है, नेक्स्ट वीक में, ठीक है। विल मीट इन द नेक्स्ट वीक, ओके। सो इफ देयर इज नो क्वेश्चन देन वी कैन मीट इन द नेक्स्ट वीक, ओके।
सर क्वेश्चन पूछना था सर, क्वेश्चन था सर, एक मिनट।
हाँ बोलो।
डाउट क्वेश्चन था सर।
अच्छा, कौन सा क्वेश्चन था?
सर दूसरा क्वेश्चन मेरे पास है सर, स्क्रीनशॉट अपलोड करना है सर।
अच्छा, तुम एक काम कर सकते हो, तुम्हारा एक फोरम है ना एनपीटीएल में डिस्कशन के लिए?
हाँ सर, हाँ सर।
हाँ, तो उसमें तुम पोस्ट कर दो, ठीक है। हाँ